In this chapter, we will begin to talk about layers, which is one of the most important concepts in understanding USD. All right, I opened the example file, and here we can see the section, what are layers? So what we're going to use this for is to kind of analyze how these layers are created as we build up our scene in different ways. But first, let's talk about what a layer is specifically. So layers in USD are simply files on disk, or a section of our scene that we've kind of cordoned off in memory, and we're going to write that out later. So there's a way that we can actually analyze this in our viewer, and that's with the scene graph layers panel here. And so this panel shows the layers that are created in whatever node tree that you're in. So here we're down at the bottom here at this Karma render settings, and in this case we can see that looks like there's two layers here. There's a root layer, and this is just like kind of the base of our scene, and then there's two of these kind of sub layers here. And so if we were to write this out to disk and save each of these layers out separately, we would get two files from it. And over here, if we look at this, we can see that there's quite a few more layers that are getting written out to disk here. So let's talk about kind of why that's happening in each of these different setups. So as we move down this branch here, we can see that, okay, we've made one layer, that's sphere 1. And as we keep going here, there's going to be either new layers added, or they'll be written on top of previously existing layers. So in this case, we're kind of just going to be going down. You're going to see that there's basically just no more than two layers at any time here in this. And so as we go down, we're just adding more and more elements here, but we still only have these two layers that'll be written out to disk. So we get all the way to the bottom here, and we only have two layers. So what we can then do with these layers that we could write out is we can use our USD ROPs. And on this one here, I have it set to flatten these implicit layers. And what implicit means is basically that Houdini is going to determine the save path that you want for that layer. It can also be saved as an explicit path, and we'll get to that in a couple of chapters as to how we do that, how we set the layers save paths. But for right now, they're just implicit, and so Houdini is going to have to kind of figure out what to do when we save this to disk. So in this one, it's going to flatten everything. It's going to flatten all these layers and basically just write out one file for us. So if I hit save to disk here, so here is the save path that I'm writing to. I'm going to open up this folder here, linear, because I'm actually using an output processor to put this all into one output directory. And under linear, we can see here, this is my linear layer scene flat. And if I open this up, this will have all of the details in my scene written out here. The sphere, ground, all of these things that have been written out to disk are all in this one file here. So that is the flattened version. And then if we look at this one here, we have the option to separate layers. So that's basically saying keep both of these layers separate. And so I'm going to hit file save on this. It's going to send an error because it's basically saying that we have implicit paths in here, and it's just kind of figuring it out on its own. So it's going to throw an error in this case. So this is how you know that you have implicit paths kind of saved in one of these USD ROP nodes. So now if we go back to that same folder, we can see that there is a layer scene separate. And here we have two sublayers, beauty and sphere 1 USDA, and those are going to both point to these two different files. But it's kind of just random the way that they're writing. This is pretty much everything is in this beauty, but that's been kind of named by this render settings node here. And if we look at the other, which is sphere, that will only have the sphere information at the very top here. And if you look closely, you can see that there's color representation for what nodes are in what layer. So here this has a purple kind of halo around it, and everything else has this kind of tan colored halo around it. Those are just randomly assigned by Solaris. But so we know that we have two layers, and really that's all we're getting there. So we don't have a lot of control. So let's look at this other option here to see how we can get a little bit more control. And we can get that by using a merge node for when we're working in memory. Now, this is not going to always work the best. And if you're bringing files in and things like that, the merge node might not be the right thing for you. So there's some caveats that we'll get to in just a short while in a couple chapters. But just know that there definitely are some caveats when using the merge node, because it doesn't always operate the way you might think it would, coming from if you have a knowledge of Houdini. So anyways, let's take a look at this and see what's going to happen here. So we get to these first two nodes and we have two layers, and we get to this merge, and now we have actually three layers because we're merging in this material library here as its own layer. So we're basically saying bring this in and merge that in as its own layer. And the reason it's doing that is because the merge style is set to separate layers. So each of these merges have their merge styles set to separate layers. So here we have another layer that's going to get added here for this assigned material. Down here we have another merge, which is set to separate layers, and it's going to bring in the camera. So the camera is going to get its own layer. Here we're going to bring all of our lights in together, and it's going to be saved on its own layer as well. And then the render settings down here will be on their own layer as well. So these have all these different layers that have been created. All right, so let's now save this into our branched folder by hitting save to disk here. And this will now make a flattened file from that. Let's take a look at it. This one here is set to flatten implicit layers. So this file will look exactly the same as the flattened file from before. So if you want to flatten everything with, you had layers, but you need to flatten it for some reason, you can easily do that by flattening your layers here, whether they're implicit layers or flattening the entire stage. So there's ways to kind of collapse everything into one file that way. Now, if we look at this branched version here and save this, we're going to get that same error because we have implicit file paths. But if we come up here, we're going to see that we have all these different USDA files that are written out. It is a bit messy though, obviously, because here's our branch layer scene right here. And basically all this is doing is sublayering in all these different USDA files that are on disk. So hopefully you can start to see how this is going to be a really powerful way of creating scenes as we move along. But at this point, these are just kind of random names that we're generating in here, and we probably need some more control over that. And in the next couple chapters, we're going to get to how to control this more and more and have these files write out exactly where you'd like them to and named the way you're hoping them to be named. Let's now talk about the layer break LOP and how it allows us to split our USD stage into multiple layers. Okay, I've navigated to the layer break section of the example file, and here we can see that we have a setup that's more or less exactly the same as the previous setups that we've been using. If we look here in our scene graph tree, you can see that there is the exact same things that we had before: lights, geometry, cameras, render settings, and materials. So that's all set up the same. Names are a little bit different, but more or less it's the exact same. So what's the difference really that's going on here? So if we take a look down this tree, we can see that we'll be starting to make layers here. And as we go down, we come to these layer break nodes. And these layer break nodes are going to force Houdini and Solaris to create a new layer in the USD file. And so we get to this layer here. We can see that there's 2 layers up here. And then we get to the layer break, that causes a new one to start. And now you can see we have 3, starting with this material library right here. It gets named after the first node in this new layer, and we continue down the chain. Each layer break forces a new one, and then we add one here, scene cam 3, and all the way down. So you can imagine by the time we get to the bottom here, we have a whole bunch of different layers that are being authored into our USD file. And the way that I'm saving them out in this example is by using these teal colored USD ROPs on the side here. So let's just take a look at what these are doing real quick. So these are set to flatten implicit layers. And so since these are set as implicit here, they're going to be flattened into this file. And so it won't be saving them out as separate layers, it'll be saving them out as one layer in the file. So that's going to flatten it and save it into the name of this node, which is layer break geometry or materials, lighting, render. So those are saving out these individual kind of sections or layers of our scene. And then down at the bottom here, we have USD ROPs that are set to kind of save out the entire scene from top to bottom. And the way that these work is we have them set in a few different ways. And so we'll kind of break that down in a second and take a look at how those USD files differ, just to see what changing some of these attributes do as we go. So let's just highlight all of these and save them. And then I'm also going to highlight these out and save them as well. So now we get an error here. That is because we're trying to save separate layers, but everything in here is implicit. There's no save path set. So because of that, it's going to throw an error. It will save it out, and we'll see kind of how that looks in a second. So I'm going to open my folder here, and this is the layer break section of our scenes. And so we can see that it's written out these three kind of master USDA files. It's written out layers, which I asked for here. These are saving to layers, each of these teal ones. And then it's also saved out this stage section. And so let's take a look at, first of all, let's take a look at these individual layers that we saved out, because these should be pretty straightforward to understand. So let's look at the geometry first, and we'll just kind of go down these. I'm just going to close some of these other ones I have open here, and we'll take a look at those in a second. So first of all, we'll have geometry that's loading. This is just saving out the sphere geo and the ground. So that's pretty straightforward. We've got those there. Let's take a look at the next one, which is materials. This one's a little longer, but it's basically saving out any the sphere surface, shaders, things like that. Just saving those out, and again, saving what's linked to what here as well, since we have a assigned material set here as well. So that's what the materials is loading. Let's see, next would be the lighting. So this is going to save out our cameras and all of our different lights in our scene here. So spots, top lights, things like that. And then finally, we have our render settings, and this is just going to save out all the different things that we're saving, that we want Karma to do basically at render time. So here's all of our different Karma render settings that are basically just the default settings, more or less. So that's saved as render settings. So that's great. Those all look really good. We have them all as separate files, and we'll use that in a second to see how we can kind of rebuild this scene from those files. But let's now go back up and take a look at these master files here. So I'm going to go from left to right in this network and see each of them. So let's look at the flat version first. This one is set to flatten implicit layers, and it's not stripping layers above the layer breaks, which means it's not going to ignore stuff that are above these layer breaks. It's using the layer breaks to start new layers, but it's not going to just ignore them completely. It's going to try to figure out what to do with them. So we're going to check that one out first here. Let's open this up. And so what you'll see is very similar to how every other version of this is written out when it's flattened. And really there's no different except maybe the names. It's written everything that we've seen in those other files into one specific place. I mean, you can see there's camera information. Down here, there's light information. If we go all the way down here, we're seeing render setting information. So when you save something out like this, flatten implicit layers and not stripping the layers above these layer breaks, it literally writes everything out into one file, which really isn't at all what we want to do in this scenario. We want to have different layers and maybe a master file that can kind of reference all of those, right? So let's take a look at this next here where we have the layer break master separate. So this is being set with separate layers, and we're not stripping the layers above the layer break. So this is going to save out the separate layers. So let's take a look at this. And so here we can see this is very different. This is very small comparatively. And we have 5 sublayers in here, which is kind of strange because it feels like we only asked for 4. But what this is actually doing is when we look at this, the end of our chain here, we can see that we have 5 layers that are saved. And that's because these layer breaks are adding new layers, but they're not saying, hey, don't ignore these maybe 2 layers that are up here, which are causing it to be 5. So it's saying 1, 2 up here, and then 3, 4, and 5. And so now we have these 5 kind of randomly named layers that are being saved to disk. And where those are getting saved is because we threw this error before, they're getting saved to this little stage section. So Houdini's smart enough to know that, hey, we're going to find somewhere on disk to save these to, but you're going to see that these are kind of a mess. We've got our materials here, our scene cameras are here. This is like the geo, and these are going to be more or less little chunks of this. Each layer gets their own thing. So this is just the sphere. If we go back to this, we'll see that there's a ground here that's in a folder, and then in another folder, and then I had an out node in there, so that's now saved as its own, and so the geometry's in that. So this has really been kind of it's kind of just an absolute last ditch effort of Houdini just to say, hey, where can we save these? We'll save them more or less with some structure from the scene that you've built in Solaris. But this is obviously not what we want. We want to have these layers referenced in a master file like this. So the last one, let's take a look at what happens here when we don't have the strip layers above layer breaks. Let's take a look at that. And here, if it's not super surprising to see, but basically this file isn't anything. There's really nothing there because we've added in layer breaks after each and every one of these things upstream. So it's basically ignoring everything that's happening in the scene and just writing out some really basic scene information. So if you check that strip above layer breaks and you're using something where you're setting new layers and things like that, or setting layer breaks in it, it's just going to ignore everything that's above it. So that can be really helpful, obviously. And then you know that if you have, maybe you sublayer something in, you throw a layer break down, and then do a bunch of changes and have a USD ROP, it'll save it out just fine like that. So that's, and it'll save out all your changes. And then you can layer that on top of it, maybe back in another master composition or something like that, a master stage that you may have set up in a different project or in a different department. So, so that just kind of gives you an understanding of how these files get saved out. So let's take a look at what we can do to kind of build this scene back up from those files now. So let's take a look over here at these sublayer nodes. And so I'm going to bring those up. And first of all, we've got this, each of these are going to load in the these teal node, the USD ROPs that were here, and by association, the USD files that were made with them. So here we can see that this is bringing in layer break geometry USDA. So sure enough, there's our geometry. This is going to bring in our materials. Right here, we can see that in our scene graph tree. This is going to bring in our lights and our camera. And here, this will add in the render settings for us. And these are going to bring in all of those layers. They're all going to be nice and neat. We don't need to do anything, there's no saving needed because these are all sublayered from disk. And that builds our scene right back up. And we could, then modify that or do whatever from that point. And if we wanted to make sure that we weren't rewriting these things to disk, when we modified them, we could add down a layer break here like this, and that'll make sure that these all stay separate and they don't get written in any ROPs that are down here. So let's take a look just finally at what this sublayer looks like when it comes in, or what the master file looks like when it comes in. So we'll just add a sublayer here. We'll call this maybe master file, and I'm going to grab that file that we made, which was in our layer break folder here. And let's take a look at the master separate there, and that should now have all of these different things in it, and it's exactly the same, right? There's nothing different here to here. Everything's the same except for the way that these layers are written. So it really would be the best thing that we could do would be to have these USDA files that are being sublayered in here be sublayered from our master file here. So we could have the most control over how we want to manipulate this after the fact. And in the next chapter, you'll see how we can even kind of go one step further and be able to tell Houdini and Solaris to put in layer breaks where we want them, but also where to save those layers. So that's what we'll be investigating in the next chapter. The configure layer LOP gives us control over where layer breaks occur in our scene, along with the added benefit of allowing us to specify a layer save path. Let's take a look at the configure layer section of our example file. So in here we have a scene that's setting up the exact same thing as we've had previously, just some simple geo, some lights, camera, things like that, and render settings as well. So this is exactly the same as the last few examples that we've used, but you can see that this is just one single column of nodes, and every so often there is one of these configure layer geometry, these different configure layers in here. So before we go any further, let me just first update this, and this is kind of an interesting little trick. We can highlight this and control click on these colors down here. You can pull that up by hitting C, and let's just change the shape of it just so we can really see what's going on, and I'm control clicking on that as well. And so now we have kind of a shape that we can very easily see, obviously, in our network. So let's take a look at what this configure layer node is doing. So first of all, here we can see that these two geometries are being created, brought in here. And if we open up our parameters, we can see here that we have a whole bunch of things that we can set. The most important things we're going to set right now are going to be the save path, this default primitive, and then down here we have what we want to do when these with these layers that are coming into the configure layer node. So first of all, let's just look here. We have a save path set to $OS, and the default primitive is just /geo. And so here we're setting the metadata on the stage root layer, which basically is just saying what's going to be our default primitive. And so we're just going to use the geometry as kind of the default primitive in our scene. And the rest of these configure layers, I'm going to turn that off. So what we want to do is flatten the input on this one, because there's actually, you can see two layers here with the colored highlights. So there's two layers coming in. We want to flatten those into just one. And we also want to make sure that we are starting a new layer. This is important. If you don't have this on, it's not going to start a new layer each time you put one of these down. So this case, we want to start a new layer. So this is the way that we mimic that layer break, is by starting a new layer. We're also setting input active layer to explicit. So you can see here that our save control is now explicit, and we have an actual save path that we've given definitively. So now each of these steps along this node tree is going to create a new layer. And this one here doesn't have this set metadata, but it's more or less the exact same. We're giving this actual asset its own default primitive. So each of these files have a default primitive, and just kind of the same thing as we go down. This one's lights. We're not flattening because we don't need to, because this is only one layer here. There's not actual multiple layers being saved. Same with this here. This is just do not flatten. So each of these next ones are set exactly the same, with the difference being what the default primitive is for each of them. And once we get to the bottom, we can see here that we have 4 layers for our 4 configure layer nodes. And that's exactly what we were hoping for. They're all set to explicit. They all have a save path. This is starting to really give us that control that we were looking for. So now let's take a look at this configure layer master. This is just set in its more or less default state. The only thing I did change was one of these output processors, and these are really great ways of kind of controlling how your output is being is being saved to disk. Here I added the match output layer extension just to make sure that if I save this as a USDA, all the rest of them will be guaranteed to be USDAs as well. And the relative paths is a really great thing, because if you move your USD file to another person, it just makes sure that all those paths are relative, and you can just open up linked USD, and it'll find those other files that are based on those relative paths. So some really cool things here that you can do with saving your files out. So just something to note there in our output processor. So in this configure layer master, we're going to be saving all reference to each of those layers. We're going to sublayer each of those in our master USDA file. So let's hit save here. And the really nice thing that's going to happen is if we open up our scenes and go to our configure layer, not only did it save out this file here, but it actually saved out in our layers folder all of the other files that we were looking for as well. So now if we open up this configure layer master, we're going to see that this is just a really simple file, and it has our render, lighting, materials, and geometry all sublayered in there. This is a very simple scene, or simple file, I should say. And it's using, like I'd said, the default primitive is set to geo. So it knows that when you load this in, that's the default primitive. If somebody's asking for just a reference in a primitive, that'll be the default. So this is a very basic file. And then if we look at these other layers here, we're going to know that if we open up something like this geometry, we're just going to have two things in it. We're going to have a sphere and the ground that was in our scene over here. So if we minimize this, we can see that's the same geometry that's in there. And then just like we did last time, we can now load in each of these individual files as a sublayer and just load them in, the materials, the lights, and the render. And now this is all super, super clean. It's all exactly the way we would expect it to come in. And if we wanted to sublayer that master file again, we can bring this in. Oh, another one, configure layer master. There we go. It'll bring in those 4 layers. You can see that this is a relative path here because it's saying it's looking into the layers, config layer lighting, and all these other files here as well. And when we look at our USD on disk, we can see that it's bringing those in as well, and it's starting to here on this layer. You can see here the exact same thing we had in our file. So this is by far the most optimized way of working. Anytime you can have a configure layer in your scene where you're maybe building things in Solaris and you want to write them to disk, that's by far the best way to be able to kind of control where those files are going. And then if you need to make a collected kind of master file or a shot master or a scene master of something, you can do that at the bottom and have all of those layers that you've created earlier referenced in using that one main file. Since we're starting to get into some depth about how USD works, let's now look at what happens when you compose primitives on top of each other. Okay, so I'm in the example file and I'm looking at this section here called examples of composition. And we have a few assets that we've loaded into this, this network box here. And they're mostly just all asset references, and they're built with the component builder so that we brought them in using the asset reference node. And if we look at them here, there's just some simple hierarchy set under here. There's a proxy and a render geometry and a materials section as well. And just as a reminder, if we come up here, we can change it to the final render look or the preview look, the proxy look. So that's just something just to keep in mind here, that we have different geometries that we can kind of see in different, render modes. And so let's just see what happens when we start to overlay something like our reference, our asset demo that we made earlier on top of this. So I'm just going to kind of reset this a little here. I'm going to clear out these variants. And so this has variants on it, which again, we'll get into a little bit later on how to set those up. But this is something that could be very commonly brought in USD. So as we talked about before, the asset reference, we can look at a very specific geometry. So let's just bring up maybe the squab here, and we'll add in a variant set for material, and we'll say the bricks. That's kind of an interesting looking one, right? So we've got our reference demo asset. So if we wire this in here, those are just going to be kind of both on our stage, both merged together basically in here. We have the two different assets, and that's all working the way we would want them to. I'm actually just going to rename this so that it's not pig asset 1, but just like that. Great. So here we have these two assets, right? And what I want to do is, instead of having this come in separately, I want to have this come in over top of the pig asset. So what I can do here is change this destination primitive. We've changed it maybe to rename it, but we haven't really ever changed it to see what happens when we actually overwrite it. And so here we're changing it to the exact same name as is in our hierarchy. We could also control click up here to bring up our picker and choose that one as well. There's a few different ways you could do it. Obviously, we've talked about that previously. But what you can see now is that this has overwritten the geometry in here. Both our preview state and our render state are both now the squab with the bricks. Now the material that was in the pig asset is still here. If you look, we have a gold material. And that is still in this here, so that's retained because we don't overwrite the gold, but we do overwrite these, so those have been overwritten. So that's kind of what happens when you, by default, overwrite the entirety of something like that. It's going to just take the entirety of that asset and just kind of overlay it. If there's anything inside of there that's different, it'll keep that, but anything that's the same, it's going to overwrite with this new object that you're basically layering in or referencing in on top of it. So that is one way of looking at this. But let's just say we wanted to use something like this. I'm just going to make a different branch here. So let's just say we wanted to bring this torus in that I have. And so this extruded torus is kind of an interesting shape, but let's just say instead of this pig for our proxy geometry, we actually wanted this torus instead. Or maybe it's the render geometry, one or the other, it doesn't really matter. But let's take a look at this and actually have it load onto the proxy geometry of the pig asset. So what I can do here is I can actually click and drag this up here and drop it in here. So this is actually going to render it over top of this. And actually I went one too far with this, because actually what I wanted to do is overlay on the proxy. So I'm just going to remove this part here, and that's going to do that. So it doesn't seem like anything has really been done here, but since we're in the final render view, if we change to the preview, now this proxy geometry is in here. Now, granted, this is very complicated for the proxy, but in this case, we have our torus now in here. And what you might notice is that the gold material has been retained. So we have overwritten the geometry, but not that material reference that was to that primitive in here. So this is still keeping the same primitive here. And what you can see here that's a little bit kind of incorrect is that this is writing this as a component now, which we really don't want it to do. So what we can use here is actually this primitive definition. We can set our other primitives to just be overlay, right? So instead of trying to say, oh, this scope proxy primitive should change to a component because that's what we've told it from the SOP create. No, let's just have it bring the shape in, leave everything else as it is, and it's just basically overlaying it, maybe overlaying, transforms or just some simple things to it. But you can actually specify just overlaying the transforms or overlaying everything else without kind of redefining what that primitive is. So that is one way that you can do this here. So what we could do here as well is we could add a material library, drop this down, and here inside of it, I'm just going to add a new principled shader. And with this, I'm just going to add in this blue cloth so it's pretty obvious. And what we're going to do here is we can just add this on top of, we can assign this to geometry, and we could assign this to the render, like so. So now what we can see is that if we go to the final render, we're going to have this blue material on it. But if we're looking at the preview render, it's gold. So in this case, we can overlay something on top of just one portion of our primitives in our scene graph tree and be able to kind of control different things like that. You know, maybe it's a lower quality shader for your proxy. There's a ton of different options there. Obviously, it's very flexible, but that's just something to keep in mind that you can do there. And then finally here, we can take this toy asset, we can wire this in, and instead of having our pig asset be kept for the shape for the final render, we can actually have this toy asset come in as the render version here. So now what we can do, well, the problem here, actually, now that I'm realizing this, is that this is actually going to bring in that entire asset at that path, and we don't really want to do that. So what we actually need to do is change the reference that we're bringing in here, because this is an asset reference, it's a reference node, and we can select from a specific part of it. So if we control click here, this is going to open up the hierarchy inside of the rubber toy asset, and we can go in here, we can find the render and the shape, and we can hit apply and OK. And so now, instead of doing it just to the render, we can add this to the shape. This is going to bring in that primitive there. Looks like I was just having a little viewport bug there. What I needed to do was just refresh this node, and it brought in the actual geometry there. So in this case, I'm taking the shape primitive here inside of the file reference and the destination primitive to the pig asset. And so now we have our pig asset here. we have the exact same hierarchy set here, but in this case we have different geometry in each of our two render settings here that we can do. So in our final render, we now have this blue toy, and in the preview, we have a gold torus. So this is the way that you can kind of take primitives and overlay them on top of each other and create differences between versions of what you have on disk, like files that you have on disk, and be able to just non-destructively add things on top of this. We haven't changed anything to the pig asset, but obviously we're making these additions down the line, and that allows you to have extreme flexibility when working in USD. And in the next chapter, we're going to kind of break down why this is happening the way it is. Let's now look a little deeper into the concept of opinions to understand how we can be intentional about controlling our USD compositions. So before we talk about anything about opinions or strength, here's just a quote from the Houdini documentation on the topic of composition. It says, "Composition in USD is a pretty deep topic, so don't be surprised when it takes a while before concepts start to sink in." So I just want to encourage you that this is going to take a little while for this all to start to click and make sense. So this is kind of just the tip of the iceberg, and we're going to keep moving through this topic as we go through this course. Now, in order to determine which value to use during composition, we can use the liver-piece mnemonic to remember the strength order in USD from strongest to weakest. And what this helps us to determine is what opinion wins when multiple primitives have the same attributes set, or when multiple layers have the same primitives present. So there's a collision of some sort happening during our composition. How do we resolve that? So here's the liver-piece mnemonic broken out, and we'll just go through from top to bottom. So the first thing we come across is local. That's the first thing that USD looks at, and that's the layer stack. So it looks at the layer stack from top to bottom and composes as it's listed there. Next, it'll look for inherits, which are a type of reference, and since they're strong, their opinion is going to win over a primitive. Maybe that's referenced somewhere else. So that's basically a stronger type of reference. Variant sets, we've seen variants a little bit through this course, and we'll be touching on variance authoring in a later course in this learning path. But for now, we've worked a little bit with variants, and hopefully you understand what that means. So next we'll find references and payloads. We've touched on those quite a bit, but those come next. And then finally, we find specializes, and those are usually pretty rare to come across, but you could look at them as a way to set like a primitive or a value to be present if nothing else in the scene expresses an opinion. So this is the order that USD will go through to try to figure out which opinion wins over something else. And these three things at the bottom here, sublayers, references, payloads, and variant sets, are by far the most common, and you really can get a lot of mileage out of just those specific elements in USD. So now let's jump into the interface and take a look at how this works in practice. So here we are in the examples of composition section of the example file, and I've made a couple small changes. I added a configure layer here, and I changed the pig asset to be using a reference. And you'll see why in a little bit, why that change was made. But first, let's just kind of go through these nodes and see how our liver-piece strength ordering is determining how each of these things compose on top of each other. So I have this little reference here that we can use while we're looking in the viewport here. And so first of all, the pig asset gets loaded in. That's pretty straightforward. Next, we have this extruded torus that's written over the proxy geometry. Here I have the preview or proxy geometry selected. And if we look over here and expand everything, we can actually see, since this little legend down here is selected, we can see that the proxy primitive has opinions in this top extruded torus layer and this geo USDA. You can see right here it says layer has opinions. So when we have these selected, it tells us things about these layers. And so we know that this LOP layer here and this geo layer, those are both the ones that it's looking at. And since the torus layer is on top, that's going to win out in the ordering, because up here you can see that local or the layer stack determines that. So this is the top layer in the stack. Next, we go to the material library. And in this case, again, this specific material is going to have an opinion that's written in this very top layer right here. That's why it's orange. So there's really nothing else to happen there. It only has an opinion in one place, and it is writing on top of the final render here, which is now this blue color. And so since that has an opinion in this top layer and the pig's material is down here in this layer, this one's going to win out. I added this configure layer in here just so that we would have a new layer started, and I just made a save path just if you wanted to save it out for some reason. But that sets that to explicit, so it's saving out this torus and material library. So now this all is the same color and is one layer. You can see this is another layer up here. And then down here, we're going to have this reference. And this was where we used the rubber toy to write over top of the render geometry. So it picks up, it keeps the material, but overwrites the geometry, right? So far, pretty much everything is pretty straightforward because this reference now is a layer that has been written on top of the other layers that were on our stage. And so there is another thing that we can do with this reference, and this is why I specifically use this reference node, because we can say what kind of reference this is, what type of reference it is. And in this case, if we change it to a payload, watch what happens. Seems like something obviously is very wrong here with the shading and things like that, but something interesting is happening here. So in this case, we've set it from a reference to a payload. And before, the reference of this rubber toy was winning out. But now, since it's set to payload, it's not winning out anymore. The pig asset is actually winning out because it is a reference, and that's higher in the order. But the very interesting thing that happens here, and I'll go over to the render shape here of our pig asset and come down, you can actually see that the normals, this doesn't have any normals, the pig by default, but it's actually taking the normals from the rubber toy and composing them on top of the pig geometry. Now let's look at how we could fix the pig head geometry to have normals so that it actually keeps its normals when we try to compose the reference on top of it. So first of all, I'm going to give ourselves a little more room here, and we're going to do an edit, SOP modify. Drop this down here. And so here we have a couple options to bring in. So first of all, I'm going to change the purpose here. I'm going to change this to render because we know that we're working with the render geometry here. And the other thing I want to do is say unpack USD primitives to polygons because we want to unpack it. And then finally, I'm going to take this rendered primitive right here and just drag it up here so that we make sure that we're actually just bringing in that geometry to edit. So let's go inside of this SOP modify. And I'm just going to hit G, spacebar G, just to kind of home ourselves back here. And so you can see now we've got our geometry in, and it is points, primitives, polygons, so it's editable geometry. I'm going to add a normal to it. It shouldn't matter if we have this as vertices or as points, but I'm going to leave it as vertices. We're going to come back up, and now we should see that this geometry should have normals on it. Sure enough, it does. When we come down to this reference here, we see as well, and I'll change this to smooth shaded, that now this has normals. It's not being overwritten by the normals from the rubber toy. And in fact, we can see that this is negative 0.92. If we go in here and look at our first normal, it should be negative 0.928, blah, blah, blah. So we know that we're getting the right attributes from our SOP context into our LOP context. So the last thing that I want to mention is that if we come down to this reference and switch this from a payload to a reference file, we will see that this does not go back to our rubber toy geometry anymore. The reason for that is that we are now authoring an opinion here under this SOP modify that's basically modifying this layer right here. It's getting saved into this layer. And so it is actually a higher priority because in our liver peas ordering, you know that L is for layers or for the local, and that is going to take precedent over the payloads or references that are getting loaded in beneath it. So in order to make this go back to where it was previously, we would need to turn this SOP modify to bypass to be able to bring to have the rubber toy geometry have the highest opinion and therefore win in that collision there when we're composing. So just something to note that there's always kind of give and take when you're working with these layers, working with references. So you have to kind of keep that strength ordering in mind while you're working with this. So now, obviously, this is a very specific case, but what I really want you to get from this is that at its core, the composition is happening at the value level primarily. The primitives are really just containers for that data. So when we have maybe two different primitives that don't have matching attributes, we just have to be careful to make sure that we know what's going to happen when all of these opinions and strengths are considered in that composition. We've mentioned the merge LOP previously, but let's now look at it in more detail to make sure we fully understand what to expect when using its different modes. So we're in the merging section of our example file. And so we have this scene built here. It's exactly the same as all the other scenes that we've been looking at previously. This scene graph tree is exactly the same. The names have changed a little bit, but it's basically identical. And so we have all of these different kind of branches that are merging together down to this final USD ROP at the bottom here. And let's just take a look at what's going on here. So we've got the sphere, we've got the ground, and then we also have a material library over here. I have some nodes grayed out because we will use those in a little bit. The bypass flag is set on those. And so those merge together. The merge style is simple merge. And you can see here that we're actually only getting one layer out of this. You would kind of think that maybe you'd have two, or in this case, 3 layers, since this has 2 and this has 1, but we're only getting 1 here. So as we keep going down, we still only have 1 layer here. We get down to the merge, you'd expect you'd have another layer here and here added in, but again, we only have 1 layer still. And then we get all the way to the bottom here and still only 1 layer. So in most USD scenes, this really isn't what you're going to want to do. If you were, say, just going to render something out of Karma, maybe it'd be fine. But when you're working with authoring USD files to disk, this really isn't going to be the way that you're going to want to go. So let's take a look at an example scene that they kind of laid out in the documentation to see how this is actually going to work. So I have another setup here that we're going to look at, and let me pull up the docs. This is the merge LOP documentation, and they've set up this really helpful guide to show you what happens when you merge something together. So I've just recreated this here so we can see this in action and be able to kind of determine what's going on. So I'm going to cover up our scene graph tree just because that's not going to be super important here. In fact, these are all just spheres, and really the scene graph tree is going to be this exact same thing the whole time. It's just going to be A through I, which is all of these layers here merged together. So we're just going to cover that up and keep this so we can keep referring to this here. So in each of these branches, we have 3 primitives, and I have this debug flag set so that will allow each of these to write their own layer. So these are 3 nodes, 3 layers, same in each of these, and they're labeled A, B, C, D, E, F, all the way to I. And the reason I'm doing it kind of in this reverse order is because I want to mimic how this is here. Basically, what this is saying isn't that this is the order of the nodes, but this is the order of the layers. The weakest layers are at the bottom here. Strongest layers are at the top. So as I go down this, you'll see stage C has been added, B, and then A. So because of the way that we, when we add nodes here, and specifically add layers, those get put on top and become stronger. So as you go down your graph, you get stronger and stronger opinions, because obviously we want those things to overwrite on top of other things that are on our stage. So that's why these are in this order. So right now we have ABC. This column will obviously have D, E, F, and then this one will have GHI. And then when we merge them all together, we would expect them all to be like this. But in this case, we have the merge style set to separate layers. So what that's doing is making sure that each of the layers that come into the merge node are kept and not flattened together. And we can see here that with separate layers, this is exactly what we're getting. We're basically taking these stacks of layers and putting these at the bottom because they're weakest, then these next, and then these. So they stay in the order that they come in each of these inputs, but those inputs get kind of restacked here. So you can see that we have ABC at the bottom, then DEF, then GHI. So pretty straightforward. Let's now take a look at maybe what would happen if we go down here and select flatten layers. We're going to come back to these two in a second. So let's do flatten layers. And of course, as you would expect, we're flattening all of our layers together here. This is just giving us G. And the reason for that is because it's flattening into the highest layer, the strongest layer that's coming in on our layer stack. So that is why we're keeping this name G, because these are all flattening up into G. So the next one that we're going to see is flatten into first input layer. And the way that I kind of like to think of this is taking everything that's coming in this first stack and more or less keeping it the same, but then taking all of these layers here and flattening them together with this top layer. And so it's keeping the name of the strongest layer in this stack, which is basically everything here, A through G. These are all getting stacked together, and then these two at the bottom, B and C, are remaining on their own. So you can see here that this is in fact what we're getting, A plus D through I, and that is being named G because that is the strongest layer that's coming in to the stack. So the last one here is going to be flatten each input. And so what this is going to do is flatten each of our different input stacks here, these branches, and they're going to flatten into their strongest. So here you're going to get A through C, and that's going to stack or merge into here. Then this is going to flatten into D. We'll see that there's a D left there. And then finally, these will flatten into G at the top. And so let's take a look now at these other two types here that we have in this list. And I'm going to connect these over here. So this top node, I'll minimize this now. This top node is just some geometry that I loaded in. And this is a file on disk. This is the pig asset. So here's our separate layers, right? So this is what it looks like when we have all of those, not flattened, where they're all separate. And so those get stuck kind of below I because they're weaker than that, but not as weak as these nodes over here. So that makes sense and should happen the way we'd expect it to. So now let's say we wanted to take those just the file layer, and have that be the weakest in the stack. We can select this, and you'll see that file layer now is down at the very bottom. So that just means that that's not going to take precedence. That's not going to have a stronger opinion than something else that would be coming in later. So that just allows you to be able to lower that opinion of that file layer. And similarly, this separate layers with the file and SOP layers weakest brings both of those down. So this is a SOP layer because we're not copying our contents into an editable layer. When we do that, it changes it into a LOP layer and it won't go to the bottom. It'll stay up here. But when we're not copying it into an editable layer, that's the real difference here. So hopefully that helps to maybe demystify a little bit of what the merge node is doing itself. So now let's come back over here and let's take a look at what we could do to kind of clean this up a little bit. So up at the top here, with this merge node, we know we don't want to do a simple merge or a flatten. So let's do the separate layers. And so now we have our 3 layers that are coming in, 1, 2, and 3. These are all, authoring separate layers. And then let's turn these layers on. And what these are going to do is, depending on what type of setup I have here in these configure layers, it's going to either flatten the input, like in this one, I want both of these flattened into one layer, and I want to start a new layer. So anything that happens after that's going to get a new layer. This one here, this material library, I also have set to flatten input layers and start new layer. And the good thing about that is we actually get the name from this node then. So now we're getting geo layer. Here we're getting material library basically on that. And then we merge those together, still have those two layers, that looks good. So now we're starting this assign material, and we are going to add a configure layer here and just allow that to start a new layer. But in this case, we can't flatten it to get that same trick going. There isn't really an easy way to overwrite the name of a layer. It just isn't something that happens. So so in this case, we can't do that flattening trick, because if we did, it would flatten everything coming in up above here and just put it in this one layer. So in this case, we just kind of have to live with the fact that this is going to be called assign material 1. And so we come down here, let's turn these on as well. And let's look at this merge. So in this case, we again have it set to simple merge by default. And of course, we'd want to change this to separate layers. And you can see already now we're getting a much better result here. We're getting things actually kept in their own layers. And this cam layer here is flattening this. So we get a nice naming convention here. And then the light layer is flattening everything above it into one layer as well. So we're getting some nice naming here with the exception of this assign material. And so here we can come down to our render settings. And again, we can start a new layer here, but we can't flatten it because in this case, it would flatten literally everything in the whole scene. So hopefully that gives you a good idea of how the merge LOP works and what its features are, and maybe what some of its shortcomings are when working with USD files. So really the best rule of thumb I can give you is when you're working with things that are Solaris elements, maybe lights, cameras, things like that, that's when a merge LOP might really work well. But when you're working with USD layers on disk, it's probably best not to go to the merge node and use something else like a sublayer or a reference. Let's take a little bit of a deeper look inside of a USD file to see what's happening there and why having a master shot or asset is a good idea. Okay, so we're looking at the analyzing layering section of our example file, and this is really, really simple. We're just using a fetch node to grab a path on our stage, which was the configure layer render, which is part of our configure layer scene. So we're just pulling that in. It's giving us all the things that we've had before in these other examples. And then we're also going to save a flattened version of this out as well, because we already have this saved from a previous chapter. And this, we're just going to save it out and look at this flattened. So let's open the configure layer folder where these files are saved, and we'll take a look at these. So let's first take a look at the flattened version. In this case, we had some geometry in our scene, a sphere and the ground. We also had materials. We had, scroll down a bit here, we have a camera, we have some lights, and really just everything is flattened, saved in this one file. So obviously with this, you could imagine that this would be really difficult if you were working in a production and had everything saved in one file like this, especially with very few references or anything like that. You would have to really reauthor this file to update it for anybody that's down later in the pipeline or for other artists, things like that. So this is often not the best way to do this for building a scene or putting things together where you can have a little more fine control of when things are updated. So this is pretty straightforward and obvious what's happening here. Let's take a look at the other, the layer master, the one that's the master file where we have the sublayers in it. And in this case here, we have 4 sublayers that are brought in. And here you can see that they go from highest or strongest opinion on top and the weakest on the bottom. So the strongest opinion is render, then lighting, then materials, then geometry. That's because they were built in the opposite order. The geometry is brought in first, then the materials, then the lighting, then the rendering. So that was the order in our tree in Solaris, and now it's the other way. It's the strength of it is referring to where those nodes were placed in the scene. So this is pretty straightforward. It's really just 15 lines of code. It's pretty short and easy to use. But the real cool thing about this is anytime you see these these paths that are inside of these ats, that means that those can be read by a custom asset resolver plugin, and that can actually look up maybe what the most recent version of one of these files is from disk. So maybe you have, some sort of a character that's on disk that you've made different versions of. Well, you can make sure that you're getting the most up-to-date, most recent version of it by using your own asset resolver plugin. So that's something really cool that you can use when you're building scenes or assets like this. So let's take a look at the other files just to make sure that we know what's going on there. Let's open up this layers folder. So again, we've got our geometry in here. The lighting, we have several, we have our camera, a few lights in here. And then the materials is probably actually the biggest file that's on disk because there's just a bunch of different shader information that's written in here. And then finally, we have the render settings, which again just tells Karma more or less what to do. And this could be any renderer that you might be looking for, could be any third-party renderer. So from here, let's move on to see what happens when we layer things on top of each other and how that ends up looking in USD. In this chapter, let's look at a scene where we're overwriting primitives to see how USD handles this scenario. So we're in the Analyzing Composition section of our example file, and we have a scene that's very similar to our examples of composition section that we did a little bit ago. And so let's just walk through this, see what's happening in our scene and our scene graph tree, and we can go from there and start looking at the actual USD files. So we have a pig asset that we're bringing in from disk. This is written over, and the proxy is written over with this extruded torus. We can see that right here. It's writing over the proxy. This also has a save path, so this is going to be saved to a separate file on disk. Then we can come down here and see that we added a material library that's writing a shader under the MTL prim, and the node is also updating the material binding on the geoprim. And so what that's going to do is write over both our proxy and our final render. So now both of those have this kind of blue shader on them. Then finally, we bring in this reference here, which is going over the render geometry. So if we go to final render, we now have the render geometry of this toy, and that is going to be, that is the end of kind of what we're doing in our scene, and then we write that out to our USD file. So let's pull those up and take a look at what's going on inside of there. So we have our composition scene right here, and under layers, we have our extruded torus. So let's take a look at that first of all. So this is a pretty simple file. Basically, we have our extruded torus here, and we have a shape. But specifically, what we see here is this word over. And so what that means is that that is an override. And the reason that that's an override is because we're taking this geometry and overriding something that was in the scene previously, namely the pig object. So let's go back to our composition scene and we'll see where that comes into effect. So here we have we're defining our pig asset. So that's the first thing, the very top of our scene, and that's a component, and we're bringing in a reference of that. There's some transformation data here, and then next we get to our geometry section because in that section, we are defining that new shader, and that is a new binding. It didn't exist before. Before, all the binding of the materials was done a little lower. It was done at the proxy or the render level. And so we're doing it at the geometry level. So that makes this a definition that it's putting in here. This is a concrete defined primitive, and that's why it's a DEF. And so that gives us our material binding here to this blue cloth. And when we look at this right here, pig asset 2 material blue cloth, we can see that this is going to be looking at this material blue cloth here as well. So that is where we're defining kind of this blue cloth material right here. So from there, you can see that we have an over, which means that this is a speculative override. So this is where we're, again, telling USD to use those composition rules we had talked about previously to make an override. And so here we're using that extruded torus, and the rest of the stuff in that extruded torus, if you remember, were overrides as well. So those are all overrides that it's doing. It's overriding the proxy with a reference, and then that has some overrides in it as well that's overriding other primitives that were written already. Then here we have another override, which is for the render. And this is the, we're overriding the shape with this reference of the rubber toy asset right here. And specifically with the, this specific path inside of there. So that's kind of neat. You get to you can actually read out what path inside of this it's pulling from. So that's how you can see where you set that path for your reference. That's where it goes right there in our USD file. And then, like I said, down here, we have an override on the material. And that material that we're adding here is going to be the blue cloth. And below it are a bunch of shaders here that were written so that the USDC knows what to do when it comes to render. So this is really the entire scene that we did here. And the other thing I want to just touch on before we're done with looking through this is the concept of append and prepend. So you'll see that these overrides here are set to prepend. And basically what that's meaning is that it's bringing it in as a stronger reference. So you can tell it to be weaker than other references or stronger than other references there. So basically that's the prepend would mean to bring it in as a stronger reference or payload, or append for weaker references or payloads. So that's just something to note in there as well, that other word that you see kind of repeated a few times here, why that exists, and that has to do with the strength ordering and opinions as well. So hopefully this gives you a great idea how to break down a file that's in this ASCII format, and when you run into something maybe that you're trying to debug, you'll be able to walk through these files and understand what's going on inside of them.